Today I'm going to talk about the unconventional oil and gas development in the United States. In the news, you can see the term called fracking, but that's not a serious term. At least you can't use that in the paper or in your proposal. HEI, the Health Effects Institute, last year reported a pair of reports. So they finalized the term. They call it unconventional oil and gas development. Okay, if you're old enough, at least for me, this should be the stereotype of oil field. Thousands of loading donkey, actually they're the junk pump, they're trying to extract oil from deep, from underground formation. Actually, this picture is taken in California. This oil field has been there for over 50 years. Some of them have very bad productivity, but they are there because they're free. America has a very long history of oil and gas extraction. To be political correctness, Native Americans should be the first to extract oil in North America. I think, I'm not sure how many, maybe 500 years ago, they used oil as a skin moisture, just like what we use as a Vaseline now. In the 1970s, America is the biggest producer of oil on the earth. At that time, the daily production is about 10 million barrels. That's a record before 2010. After that, fracking changed everything. If we look from above, this should be conventional oil and gas field. You can see there are a lot of small well pad. Every small well pad holds a single loading donkey. Now, believe it or not, a lot of environmental report use this pair of pictures to show how disruptive the fracking is to our life. But, because they look very impressive, you can see a lot of well pad. But actually, they are not fracking. They are just a very common conventional oil and gas field. What's a fracking well look like? This is what it looks like. In the right corner, you can see half of the remaining part of an old conventional oil and gas well pad. That's partially removed to make space for a new well pad. For the fracking well pad, firstly, it's large. You can see it's about 10 times bigger than a normal conventional oil and gas pad. Another big difference is that you can always find a wastewater pond nearby. Here is on the left side. That's where the hydraulic fracturing comes to play. After finishing all the pad, you can see it looks peaceful. There are not a lot of activities nearby, but during the construction stage, you can see this is a fire construction. It's labor intensive. It always occupies over 100 people for a single well pad. It's water intensive because every single well needs over 100 million gallons of water, fresh water or salty water, whatever you can get. The water is okay. To make that impressive, I calculate the capacity of the M2 shuttle. Every single shuttle can take about 24,000 gallons of water. So to finish a single well, you need over 4,000 rides of M2 shuttle just to take water to the well pad. Let alone there are some other chemicals that you need to build an apartment for the workers. So that's a lot of labor and a lot of facilities. And of course, they need a lot of money. So on average, at the end of 2017, the average cost, and just mean the drilling and construction of a single well, is about $4 million. And at the same time, United States has drilled over 120,000 wells. So if you can calculate on the back of the envelope, You can see how much money United States has already invested in this industry. That's all. If you remember, last time in the last lecture, Professor Kutrakis mentioned that the average lifetime of a power plant is about 30 years. And if you combine these two factors together, you can imagine that, okay, fracking cannot be banned in the foreseeable future because they need to get their money back and we need them to feed the power plant. Okay, let's start. Then we need to know where's the source of the oil and the gas. On the left side, this is the extent of Marcellus Shale. This is the most famous shale in the United States because the development of fracking in it. The red points are the location of the wells. And on the right side, on the red panel, this is the sea level in the mid-Devonian period. It's about 400 million years ago, even before the dinosaur. You can see at that time, a light chain basin is covered by a very shallow ocean. You can call it lagoon or whatever you call that. That's the most productive part of the ocean. If you love fishing, you know that. If you ride very far away from the shore, you can't get a lot of fish. But if you go to the tidal area where the flooding and ebbing every day, it's very productive. There are a lot of fish there. That also means there are a lot of, in millions of years, it left behind layers of organic matter-rich sedimentary rocks. That's the source of oil and gas. That can explain why the two polygons are so similar. This is only one of the oil and gas formation process. That's not all, but that's only one of them. Okay, after being buried under the crust for millions of years, the big molecules, the molecules of organic matter are broken into smaller ones. There are always mouths underneath. There are two types of molecules for the crude oil and the natural gas. Natural gas, we know it's methane. Crude oil is called octane. Under the heat underground, they need to move forward because they're lighter, just like air. When we hit the air, it goes upward. If there's a trap, what is a trap is always some layer of rocks with very low permeability or with very low porosity. There's no space the molecules can cross it. It forms a trap. When there's a trap, the oil and gas was trapped underneath it and it accumulated. That's what we call conventional accumulation. That's a source of conventional oil and gas and unconventional. What's unconventional? It's a source of these molecules underneath. To summarize the difference, for conventional oil and gas, they have very high permeability. They have very high porosity. They can flow. Sometimes the porosity is so low, the liquid, such as the crude oil, can flow within the formation. But it's also discrete. What I mean discrete is that from the left-hand side, isn't that not continuous? From the source formation, that's maybe miles underneath them. You can see it's continuous everywhere, but the density is much lower. When it's concentrated, it's not so continuous. It's discrete. The conventional oil and gas is always shallow. Last year, Iran found a big reserve for the natural gas. The average depth is only 80 meters, only 80 meters. But the average of depth of the unconventional oil and gas is about 3 kilometers. That's the difference. That can explain why it's so cheap to produce natural gas and oil in the Middle East, but it's so expensive in the United States. To produce them, we don't need fracking. What we need to do is just to drill directly into the formation. That's like what the left one said. Just use a vertical drill directly into the formation. Under the pressure, the carbohydrate will get pushed out. But for the unconventional, where they have low permeability, they have low porosity, that means they cannot flow freely within the formation. You need to enlarge the collective area first. But the good news is that because they're continuous, you don't need to try a lot. What you need to do is to drill deep enough and get into the formation. That's all. Here's a picture made by EIA, the Energy Information Administration. It's a branch of Department of Energy, so that's the official part. They can say after drill, there's a directional drilling here in the middle. After drill, use a vertical drill into the formation. You need to follow the direction of the shale. If you drill out of it, as I mentioned, in America, it's formed over the ocean. There are a lot of saline water. Saline water, that means the concentration of salt is pretty high. If you get out, what you extract is not oil and gas, yeah, just salty water. It's a waste of money, it's a disaster. So you need to follow the direction of the formation. But for the conventional oil and gas, what you need to do is know the exact location of that reservoir and drill inside. So this is the process of construction of a well. Firstly, you need to do the survey to make sure there's some oil and gas underneath. And then you need to negotiate with the landowner in case you need a permit to build a well to get the oil. Now, the land ownership is a little tricky here. For example, in Texas, it's common that the landowner on the surface, that the owner of the building on the surface, is also the owner of the manor underneath. In that case, the owner can get some royalty, the monthly royalty. But in Pennsylvania, maybe 100 years ago, at that time, the residents on the surface also has the ownership of the manor underneath. But during the development, the land was divided into some small pieces. The owner of the small pieces doesn't have the ownership of the manor underneath, because 100 years ago, at that time, the previous owner has sold it to the oil company. So technically, the oil company has the ownership of the mineral. They have the right to come to our backyard to drill, to get what they deserve to get. What they only need to pay is the damage they caused on the surface. That partially explains why in Pennsylvania is so controversial. You can't hear that in Texas. After drill directly into the formation and the lateral drilling, you have the drill hole. What you need to do next is fracking. That's the process of fracking. It means you need to mix fresh water with some chemicals. There's some biocide to kill all the bacteria. Okay, William. Okay, I got your question. Okay, why is it so controversial in Pennsylvania instead of Texas? I say in Texas, every block, every landowner has a very large farm. They have the full ownership of the ground surface ownership and the manor underneath. Maybe that's the case for Pennsylvania 100 years ago. But at that time, there's a rush for the oil underneath. At that time, the owner sell the ownership of the mineral to the oil company. After that, due to the urban expansion, the large land was separated into some small pieces for the current residents. When they sell the land to the current resident, they didn't sell the ownership of the mineral underneath. They only sell the usage of the ground surface. The ownership of the mineral belonged to the oil company. At that time, they don't know there's some shale underneath, so they almost abandoned that. All of a sudden, they know there's some natural gas underneath, so they come by to claim what they deserve to have. The residents cannot stop them because the ownership of the mineral underneath belongs to the oil company. So they can come here and drill. But they also cause some damage to our property, so need to pay for that. But the owner of the ground surface construction cannot get any royalty, because that doesn't belong to them. Does that answer to your question, William?
Yes.
Maybe. Okay.
Yes.
Okay, let's move on. Okay, to save money, the oil companies always cluster all the well pads together. You can see there are two constructions side by side. There's a wastewater pond. When you inject large volume of water underground, sooner or later it will be pushed back because the pressure underneath is so high. When it gets back, it's not the water you inject maybe 3 days ago. It's a combination of radionuclides, chemicals, and some other particles. They can't be used directly. So you need to put in the wastewater pond. And you can see a lot of trucks. Actually, there are a lot of engines. As I said, you need huge pressure to inject water into the well, into drill hole to create some cracks. How to have such big pressure in the middle of nowhere? You need a lot of engines. Sometimes you need over 100 trucks to create enough pressure. That causes a lot of emission of particles and the NOx and some other air pollutant. Okay, this is an actual case of a fracking well. If you look above, the orange line is the trajectory of the well bore. You see, on the right side is the profile of that. Firstly, it goes vertically to the formation. Then it goes laterally, follow the direction of the formation. You can see the drilling depth, the vertical depth is about 9,000 feet. And the horizontal length is also 9,000 feet. It's about 2 kilometers. That's pretty long. And as I said, on a single well pad, there are a lot of wells. Because for the conventional oil and gas, you can't put too many wells on a single well pad because they can get into each other. It can cause some problem. But for the unconventional, you can put not as many. Over 20, I think 20 is not a problem. You can put as many as 30 wells on a single well pad, and they can go different direction, so they won't collide. Actually, on this well pad, there are 64 well pad. That's an experimental well pad. The productivity doesn't meet the expectation of the oil company. That's why it's almost abandoned. Okay, in this area, you can see all the trajectories of the horizontal wells, or directional wells. On the left corner, you can see an area. Actually, that's the source of the first picture I showed you for the conventional oil and gas. Even though it looks very impressive, you can see a lot of well pad, but actually that's not the fracking wells. That's just some almost abandoned conventional wells. In the other parts, you see, the fracking industry almost occupy almost all the underground minerals in this area. This is a part of Texas. Okay, let's have a look at the expansion of fracking well in the United States. You can see after 27, the expansion of oil and gas in Pennsylvania exploded. It goes so fast. Every single dot is a well. You can see the state level regulation is very effective to stop the expansion of fracking, especially on the border between New York State and Pennsylvania. You know, there's almost a straight line. From the previous slide, you know, the Marcellus Shale extends directly into the New York State, but there are almost no well there. In the past 20 years, over 130,000 wells were drilled in the United States. There are some big event happened from 2014 to 2015 because that time Saudi Arabia want to push the fracking business away, out of business. So they flood the energy market with very low price oil on purpose. But a big advantage of fracking is that just like there's some switch on the wellhead, if the pressure is not high enough, you can turn it off and let the pressure accumulate. After maybe 3 years, when the pressure recovered, you can reproduce. It does not like the conventional natural gas production. You know, you have to keep the pressure. If you don't need the natural gas, you need to burn them. But for the fracking, you can just need to turn off the wellhead and wait another 3 years. That's part of the reason the fracking industry in the United States can survive that disaster. And the expansion of fracking enabled the United States to be a net energy exporter after being the big user for 50 years. And there are a lot of control. The fracking is very controversial. Firstly, you know, the Obama administration brand the natural gas as a bridge energy, but nobody tell you how long and how wide the bridge. Actually, you know, from my own perspective, the United States gets addicted to natural gas because it cuts the emission level so much. It's an easy way, but to further cut the emissions is more difficult without natural gas. And the fracking activity has been linked to a lot of environmental impacts. Most of them are negative, such as the increased level of VOCs, NOx, and the noise, the light at night, and there are a lot of water contamination reports. And partially due to these reasons, there are a lot of studies connecting fracking with some health effects. You know, I think the most important one about respiratory outcome, just like the occurrence of asthma and the cardiovascular disease, but the link is not that solid because of the long latency.